Before we go into next topic, I would like to say something more about RC curve and the coefficient metric. Here is the view graph from Wikipedia. One of the figures looks like this. Okay, usually we have certain features, for example, x1, okay? And here, we have a very simple model, which is just a line. For example, this point is xa, okay? So this model is very simple. If x1 larger than xa, then we say it is y equals to 1. And the right hand side, y is plus 1. Left hand side, y is minus 1. This rule is really simple. Just a number, depending on is larger than xa or larger than x, smaller than xa. So of course you can have several different parameters, right? So basically, okay, you can easily create another model, the green one. You can simply use another model like this. Model 2. As we can see, there are different set of data, which is on the one side is y equals to plus 1, which is right here. Y equals to minus 1 is right here. However, this part, there's some data which is overlapped. Some of the data, the label is marked as y equals minus 1. However, their x1 value right here is larger than xa or even larger than xb. 好，中文上来说就是说，这样两份资料嘛，一个是 y 是正一的，一个 y 是负一的。那我们用 x1 这个 feature 来去评估它的时候，你就随便切一刀嘛，一刀两断嘛，哈。可是问题是你切在哪里都不太好，为什么？因为这个资料是 overlap 的，而生活中的资料也通常都是 overlap 啊，也就是说呢，你可以找到有一个 y 是负一那边的东西，可是它 x1 的值啊很大，大到超过 a 跟 b 的，对吧？会 overlap 嘛？而且有的时候你可以找到 y 是正一 ，y 是 label 成正一的时候啊，它的 x1 的值啊，已经小于 b， 甚至小于 a 了，好，就在左侧。可是由于你的 model 太简单了，你只能一刀切，那你到底要切在这里面的哪里呢？就是一个很困难的问题了啊。也就是说呢，同样是一个 model， 是因为参数的不同，所以导致于说你可以在这边做调控。那通常而言呢，以这个例子来说了以这个例子来说，那一刀要切在哪里呢？当然就切在正中间这里，对不对？切在正中间这里，它刚好会涵盖到它的右侧都是 y 是1的，涵盖左侧都是0的。那下面怎么办？下面这个三角形怎么办？它就是全部都是错的。怎么错？就是说是1的，但是是负1的嘛；说是负1，但是是1嘛，就是错的。So this is a very simple explanation of false positive, false negative. And we can see that the blue part is true negative, right? It's true negative because y minus 1, y plus 1. Because there are some data points that are originally labeled as minus 1. And your model, which is this black line, says, okay, this is less than a certain value, for example, a. So the blue parts are all correct, true, negative. On the contrary, at the right hand side, the red parts, okay, all those red parts are data points that labeled as y equals plus 1. And your model, which is the black line, says, okay, they are all larger than a, x1 larger than a, so they are true positive. Okay, so here's the true positive. However, if your model is very simple, like this one, just a line, just a number, okay, cut these data points into two parts. There should be false positive and false negative, which is marked as these two areas. If you move your model, okay, along with x1, so at certain point, you will have a false positive rate right here. and false true positive rate right here. If you move your model to the right hand side, what is that means? That means your true negative rate increase and your true positive rate decrease, 对不对？当如果你把你的那个黑色那条线，然后一刀切两半的线往右移的话，那你想你红色的面积一定变小嘛？那可是你红色面积变小的时候，你蓝色面积就变大了。红色面积变小，意思是说是正一，那你判断是正一的量；是蓝色的面积的话，是它原本是负一，但是你判断是负一的量嘛？这完全就 trade off， 因为资料是交叠的嘛。这理由完全就是因为资料是交叠的。所以如果你把你的线往右移的话，你红色就会变小，对不对？可是你蓝色会变大，这怎么办？那个线会应该是从这紫色点往左下角才一样，对不对？因为你的 true positive 变小了嘛，可是你的 true negative 变大了。你的 true negative 变大，就是你的 false positive 变小的。Okay? So if you move your model line, which is from A to the right hand side, and at the ROC curve, okay, your data point goes to the left bottom direction. Okay, if you move your model to the left hand side, which means you increase your true positive, but you decrease your true negative rate, and then you increase your true positive rate, so your model goes this way, which is in green color. So it's really depends on your application. Usually, as I say, usually we select the data point which touch the diagonal line. Usually we select it, we view it as a trade-off. Okay, we have a very nice true positive, we have a very nice true negative, and also we have false positive and false negative. But for some application, as we mentioned before, for example, y plus 1 means has cancer. The left hand side minus 1 has no cancer. So for such kind of application, you want the high true positive or you want to have a high true negative. 就是说，在不同的 application 里面，其实你不是只是选一个中间的 trade off 的点而已，你要看你的 application。像我们那个之前讲的癌症这个例子啊，你当然是希望我说那是比较惊险哈，你当然是希望你被model 判断成有癌症，但是实际上你没有癌症。再讲一遍，你希望的是你被 model 判断成有癌症，但实际上你没有。因为你可以做很多次的检查，对不对？我们讲这个 model 只做一次检查，你可以做很多次不同的检查，让你的 true positive 变很高。就你有癌症，你一定要知道，你不可以不知道。所以你通常会把这条线往左移一点，你让红色的区块变大，对吧？然后左边蓝色区块不是变小吗？可是蓝色区块变小的时候，就意思是说，有时候你没有癌症，可是你被误判为有癌症嘛。可是没关系，你可以做第二次检验，做第三次检验，做第四次检验。但是有一些 application 就是那个红色那个区块要越大越好，越大越好。你有癌症就一定要被检查，你不能够漏判。你可以误判，可是你不能漏判，这个是医学上的要求。所以这个时候你就会把线越往左边调越好。你宁愿牺牲true negative， 可以吗？要记得哈，这个不是一定的哈。这个往左往右就会对应到下面那个ROC curve 往右上比较右上一点，还是往比较左下一点？这完全是，所以有的时候你做一些商院的，比如说财经的资料啊、医学的资料，很明显就是你不能够做错的。比如说你判断一个人有没有癌症，你不能做错嘛。你判断一个人会不会不缴钱违约，信用卡会违约，你最好都不要做错。你宁愿是把你说误杀好人，误杀好人你可以复查、复查再复查，对不对？就是要记得哈，会有这些 application。